Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can evaluate logarithmic functions when they're perfect answers, meaning that there's not going to be any decimals that will go on forever, things like that, stuff that we can find what that answer is immediately based on our knowledge of exponents and powers. So using that idea, we're going to explore these logarithms. If you have questions about what we're doing when it comes to rewriting logarithms as exponentials, or about what a logarithmic function is, be sure to check out the previous videos in which we discuss those things. So when it comes to evaluating logarithmic functions, what we want to make sure we know how to do is rewrite something as an exponential. So remember, a logarithmic function is repeated division, saying if I take whatever that number I'm putting into my function is, so in this case, the number 16, how many times do I need to divide that number 16 by my base, which is 2? So how many times do I need to divide 16 by 2 for it to equal 1? Because 1 is the simplest number. By doing so, our answer to our logarithmic function is 4. How many times do I have to divide 16 by 2 until it becomes a 1? 4 times. 16 divided by 2 is 8. That's the first time. 8 divided by 2 is 4. That's the second time. 4 divided by 2 is 2. That's the third time. And 2 divided by 2 is 1. There's our fourth time. So what we want to do is be able to rewrite those as exponentials. So again, we went 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And that 2 divided by 2 is 1. So because it took 4 steps here, we know it's going to equal 4. Now, what happens if they don't tell us what it equals? Well, that's what we're going to look for here. So in this case, we've got the question log base 4 of 64. So I'm asking myself, how many times do I need to divide 64 by 4 until I get down to 1? Well, what is 64 divided by 4? Well, if we divide it first, 64 divided by 4 is going to be 16. So then what happens with my 16? Well, 16 divided by 4, well, that's equal to 4. And then we do our 4 divided by 4, which equals 1. So according to my division, using that logarithm, it took 3 whole turns. Now, how can I check to see if that's right? Well, remember, we can always rewrite a logarithmic function as an exponential. So we need to ask ourselves, is 4 to the power of 3 equal to 64? Well, when we try that in our calculator, the answer is yes. So what we're trying to do here is figure out basically 4 to what power is equal to 64, because that's what we're going to find. Now, this idea of repeated division works out fantastic when it's a number that's bigger than 1, so 64, something like that. That's not a fraction, and our base is not a fraction. However, when we start getting things that are more complicated, it gets a little more complicated. So let's take a look at this one here. So this question is saying log base 5 of 0.2. Well, I'm going to rewrite it as a fraction because that makes it better. So we've got log base 5. And when I say better, what I mean is it's more applicable to us. So I can see 0.2 doesn't mean much to me in terms of 5. However, if I rewrite 0.2 in its fraction form, which is 1 over 5, all of a sudden, I see that relationship between those 5s. So now I'm asking myself, 5 to what power is equal to 1/5? Or what do I need to divide 1/5? How many times do I need to divide 1/5 by 5 to become 1? Well, one handy trick that we know is anything to a power when it becomes a fraction means we're putting it to a negative power. So this case is actually 5 to the negative first power, because what we're doing is we actually are going to take our 1/5 and multiply it times 5, or in this case, we're going to take our 1 and we're going to divide it by 5. Because remember how that exponential works is that we have a -1, a 0, a 1. So if 5 to the power of 1 is 5, 5 to the power of 0 is 1, we're just going to divide by 5 here. So to get that 1/5, we divide by 5 and we get 1/5. So that's kind of how those work with those negative exponents. Let's take a look at a couple more examples here. So in this case, we are looking at what we need to do to go this way. So in this case, I have 125. I want to know how many times do I need to divide that by 1/5 in order to get the answer of 1. Well, I'll give you a hint. If I do 125 divided by 1/5, I'm going to end up getting 625. So I can tell you, based on that information there, that my exponent is going to be negative because I don't want to divide by 1/5, but I actually want to multiply by it. I need to go the other way. So I'm really looking for 1/5 to what power equals 125. Well, an interesting thing that we can look at is 5 to what power equals 125? Well, 5 to the power of 3 is 125, right? So if 5 to the power of 3 is 125, I bet 1/5 is going to be -3. So then we can try it that way. So 125 to the power of -3 is going to, or not 125, 1/5 to the power of -3 is going to be 125. That's what we're looking for. And we can see that that is the case because we need to, oh my goodness, writing and talking at the same time. We need to take that 125 and we actually need to divide it by a +5 or multiply it by 1/5, which is the opposite of what we were doing before. So that's kind of how we can evaluate those. Let's take a look at one last example here of what we would do to evaluate this logarithmic expression. So in this case, I've got log base 36 of 6. So going back to our understanding of logarithms, we're saying 6 divided by 36. How many times will I need to divide 6 by 36 until I get 1? That's what we're looking for here. Well, if I do 6 divided by 36, as you just saw, we're gonna get 1/6. And that is not equal to 1, right? And if I keep dividing that, it'll go to 1. It'll keep getting bigger and bigger. So we know that this needs to go the other way because what we're looking for, it's 36 to what power is equal to 6. Well, what power does that need to be? Well, I know that 36 is the square root of 6, meaning that if we were to write a square root as an exponent, we have a 1/2 there. Okay, so this actually ends up equaling 1/2, and we can double check that. So there are lots of different ways to do it. And you can see that that we are able to find these answers doing it this way. However, sometimes the numbers aren't going to work out perfectly. We're going to run into situations where we see something like log base 2 of 10, where I ask myself, how many times do I need to take 10 and divide it by 2 until I can get 1? Well, 10 divided by 2 is 5. 5 divided by 2 is 2.5. 2.5 divided by 2 is going to be 1.25. You can see we're getting close here, but once I take 1.25 and I divide that by 2, all of a sudden I'm running into a problem here where I've only got 0.625. Now I'm past it. So it's going to be somewhere between 2 and 3. So how do I figure out, or somewhere between 3 and 4. So how do we figure out what that is? And we're going to talk about ways to evaluate logarithmic expressions when this idea of just repeated division isn't going to work out perfectly because it comes in between. So please check out the next video in which we talk about some common types of logarithmic bases that we see on our calculator, as well as what we can do when we run into the problem where it's not one of the calculator bases and it's not something that works out perfectly. So check out those next 2 videos to see how that works.